Good day to all my viewers around the world. Once again, you're welcome to my YouTube channel. Before we proceed, don't forget to like, share, comment, and subscribe to this channel. Thank you. All right, for today, we have a question from Nigerian Mathematics Olympiad, junior category first round for the year 2015-2016, question 13 and 14. Let's take a look at it one after the other. The first question there, which is question 13, says, find the radius of the circle that is tangent to all three sides of a triangle ABC, given that the triangle has lengths 7, 24, and 25. I repeat, find the radius of the circle that is tangent to all three sides of a triangle ABC, given that the triangle has lengths 7, 24, and 25. How do we solve this question? Let's take a look at how we can provide solution to this question. Okay, here we have solution to this question. All right, for the solution to this question, how do we solve this? Let's take a look at this diagram. We'll sketch out the diagram, and from the diagram, we'll be able to solve the question. Take a look at this diagram here. Three sides are given. We have 7, 24, and 25 based on what we have in the question. Okay, now how do we go with this question? I'm going to show you two ways of solving this question. The first one, we're going to use the property of a tangent. And the second one, we'll take a look at another approach of solving this question. Okay, let's use the property of tangent first. This is the center of the circle. We have the center of the circle here. And if I draw a line here, which is the radius, it touches this tangent here. So it is perpendicular to this tangent, okay? And also, if I draw this down here, which is also the radius, if I take it down, it is also perpendicular to this tangent, all right? And taking a look at it, this is a radius here. This is also a radius. And I can as well bring this one to this side here. So from here to here is also our radius. If from here to here is radius, automatically from here to here is also a radius. And also from here to here is a radius. And taking a look at this side here, if from here to here is 7, and from here to here is our radius, automatically for us to get this side, of course, is going to be 7 minus r. So from here, from this side to this side, okay, is 7 minus r, okay? And let's take a look at this one too. From here to this point here is 24, okay? If we're to get from here to those points here, okay, that's going to be, the whole of this one is 24. To get this point to this point here, the distance there, we're going to have 24 minus radius. Okay, that's what we're going to have. And according to the property of tangents, we all know that this from this point to this point is equal to from this point to this point. That means this side is equal to this side, okay? And also from this part, this side is equal to this side. So if this side is given to be 7 minus r, automatically this side will also be 7 minus r. Okay, and from this side here to this side, if it is given to be 24 minus r, so automatically, if you have it from here to this point here, it's going to be 24 minus r, and down to this point here, okay? So from this point here to this point is 24 minus r, and from this point here to this point here is 7 minus r. And also we're given the whole of this length to be 25. So the first method now, so the first method will lead us to 7 minus r plus 24 minus r, and we equate it to be the total length, which is 25. That's 7 minus r, okay, plus 24 minus r is equal to the total length, which is what? 25. All right. So from what we have here, we can collect like term, okay? That means we have minus r here will give us minus 2r, okay, which is equal to 25, okay, minus 7 plus 24, that's 31. If you bring 31 to this side, it becomes a negative sign, okay? That's going to be, that's going to be 25 minus 31. And this is going to give us minus 2r is equal to minus 6. So we divide both sides by the coefficient of r, which is minus 2, and this is also minus 2. And from here, this we cancel this we go with this, minus we cancel minus, okay? Radius from here, 2 here 1, 2 here is what? Is 3. So radius is equal to 3. So from this, our radius is 3. Now, taking a look at the second approach or the second method. Second method, radius is going to be, we have area over semi-perimeter. Semi-perimeter of the triangle, okay? Area of the triangle over the semi-perimeter of the triangle. So to add the area of the triangle now, we have half base times height, okay? And here is going to give us 1 over 2 times, what is our base? Our base is 24 here. So times 24, then times, what is our height? Our height is 7, okay? Then we have times 7. So here we have 2 here 1, 2 here 12. 12 times 7. So this is going to give us 84. 12 times 7 is 84, okay? So we're done with that. Let's take a look at the semi-perimeter. Semi-perimeter of the triangle. Semi-perimeter is the addition of all the sides divided by 2. So here we have 7 plus 25 plus 24 divided by 2. And this is going to be 56 over 2. So we have 56 over 2. And if we divide this, that will give us 28. So this is 28. All right. All right, on a final note now, to find the radius now. To find the radius is equal to area. What is our area? Area is 84 over semi-perimeter is 28. Give us 3. So this is another method. All right, the next question. Triangle PQR is an equilateral with side length 12. Find the in radius of triangle PQR. Find the in radius of triangle PQR. All right, let's take a look at the solution to this question. For the solution to this question, how do we solve this question? To solve this question, let's take a look at the diagram first, and then how we're going to pick it from the diagram there. This is the diagram. This is the diagram, and we have it to be equilateral triangle. That means this side is 12, this side is 12, this side is also 12. That is one of the properties of this equilateral triangle. That is one of the properties of equilateral triangle, okay? And also one of the properties of equilateral triangle is this angle is equals to 60 degrees, okay? This is also equals to 60 degrees. This is also 60 degrees, okay? Okay, I'm going to draw a line from the center here. Now this line from here, take it to the center. Also from here, I'll draw a line down to the center here, and from here goes to this angle here. So automatically this angle here is 30 degrees, okay? And this is 30 degrees because this line bisects this angle into 2 equal parts, okay? And this is also 30 here, and here is also 30 degrees. And okay, so from there, I'll bring this down as well. Okay, bringing this down, this is 90 degrees because this line is perpendicular to this line. Okay, this is 90 degrees here. And if this is 30, automatically this is what? 60 degrees. Okay, now from this triangle, the sum of angles in a triangle is equal to 180. So this is 90 plus 60 plus 30 is equal to 180. All right, so from here to the side is our radius. And solving this as well to get the radius of this, I'm going to use two methods as well to solve this. Let's take a look at the first method. First method for this. Now I'm going to bring this triangle out. Bringing this triangle out, this is what we'll be having. Here we have radius, okay? And also this line, it divides this into two equal parts, okay? It divides this line, divides this part into two equal parts. So this is 6 here. This is also 6 here. And here, if I'm bringing this out, this is angle 60. This is 90 here. This is 30. And this is 6. Okay. And what we're looking for is radius. So to find the radius here, we're going to use, we can decide to use 30 degree or 60 degree. But for this 30, I want to use 30 degrees. That's 30, we have opposite over adjacent. Opposite over adjacent gives us tan. So we have tan 30 degrees is equal to, opposite is radius, which is r, over adjacent is 6. So r, which is radius, is going to be 6 tan 30 degrees. Okay, and radius is equal to 6 times, what is our tan 30 degrees? That's 1 over root 3. Okay, so we have 1 over root 3. Here is going to be radius is equal to 6 root 3 over 3. That's if you rationalize the denominator here. Rationalizing this becomes 1 over root 3 times root 3 over root 3. Okay, so 3 here 1, 3 here is 2. You can see the final answer for our radius is equal to 2 root 3. So 2 root 3 is the radius of this diagram that we have here. For second method, how do we go with the second method? Okay, for second method here, we're going to use this formula for the radius. Radius is equal to a square root of 3 over 6. This is the formula we're going to use. A square root of 3 over 6. Where A is the side of the equilateral triangle. That means we have the sides of a 12. Okay, so A is 12. So substituting A there, we have 12 root 3 over 6. 6 here 1, 6 here 2. And the final answer is 2 root 3. So this is the solution. You can see that what we have here is the same thing with what we have here. So this is the solution to this question that we have here. So today we have come to the end of today's class. I believe you have learned 1 or 2 things from today's class. Don't forget to subscribe to this channel, like, share, and comment. Till we see next class.